Hi everybody. We're going to look at equivalent fractions now and talk about what exactly an equivalent fraction is. So two fractions that describe the same proportion are equivalent. So let's demonstrate that. Over here we have three circles. They're all the same size, and in each case we've shaded a half of the circle. In this case we've split the circle into two equal parts. You have to excuse my wiggly line. And so out of the two parts, one part is shaded. That gives us a fraction of a half. In the second case, we've still got half of it shaded, but we've split it into four parts. That's why there's a 4 in the denominator. And we have two parts shaded. So there's a 2 in the numerator. We say that these two fractions are equivalent because they represent the same amount of the shape that's shaded. In the third case, we split it into 8 parts, and 4 of the parts are shaded. We still have half of the object shaded in total, but we've got it in 4 separate parts this time. So half, 2 quarters, and 4/8 are all said to be equivalent. Now, as we know, there's lots of different ways of representing fractions. So here's a fraction wall, and in the fraction wall we can easily see lots of fractions that are equivalent. In the case of a half, from here to here, 2 quarters is the same area as a half, and 3/6 is the same area as a half, and 5/10 is the same area as a half, and 6/12 is the same area as a half. All of these fractions that end at the same point on our fraction wall, even this 4/8 here, are said to be equivalent. Now, we could see that 2.5/5 would also be, but we don't really talk about fractions in terms of halves of fractions, in this case half of a fifth. So we're going to ignore the fifths, and we're just going to talk about quarters, sixths, eighths, tenths, and twelfths. They're all equivalent to halves. Okay, now, arithmetic can help us find equivalent fractions. And the easiest way to do it is to multiply by the different versions of 1. We can represent 1 as 2 divided by 2. 2 divided by 2 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. And as long as we're multiplying by 1, we don't change the quantity associated with the fraction. So if we wanted to find an equivalent fraction of a half, we could multiply by 1 by 2 on 2. And that would give us 1 times 2 is 2, and 2 times 2 is 4. 2 on 4, as per our equivalent fraction at the top here. Similarly, we could multiply by 3 on 3. 3 divided by 3 is also 1. Anything times by 1 is itself. So a half times by 3 on 3 is 1 times 3. That gives me a 3 for the numerator. 2 times 3 is 6. That gives me a 6 for a numerator. Gives me an equivalent fraction of 3 on 6, which we can see here, 3/6. And similarly, we could do it for 4 on 4, which is also 1. Half multiplied by 1 gives us 1 times 4 is 4. 2 times 4 is 8. 4/8. Here's our 4/8 here. We can see that it's equivalent. So on and so forth. We can do 5 on 5, 6 on 6, A on A, anything. A quick reminder that if we're going to multiply two fractions together, we have to multiply the numerators and the denominators. It's unlike addition, where we only add the numerators. When we're multiplying, we multiply both. So here, a half times 2/3 would be 1 times 2 and 2 times 3 to give us 2 times 6. Now we're going to look at multiplication a little bit more later when we're doing fractions of amounts. But for now, that's why this is working, because all we're actually doing is multiplying. So let's do some pictorial and with arithmetic. And when I'm talking about arithmetic, I'm talking about with numbers only. So if we wanted an equivalent fraction for 3/4, we could split each of these into half, which I've done here. So we'd end up with 1, 2, 3, 4, 5, 6, 7, 8 equally sized parts. There it is there, of which 6 of them are now shaded because I've split each of these in half. And that would make 1, 2, 3, 4, 5, 6 parts. Now I could go further than that, and I could split each of these parts into 3 parts. So if you can imagine, that there is this part here, and I've split it into 3 bits. And that would give us 12 parts, let's count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And of those, 9 are shaded. Now if we wanted to do that with arithmetic, we want to make 12 parts, we'd multiply 4 by 3, that would give me 12. And to make sure I'm multiplying by 1, I'd multiply by 3 on 3, which would mean we'd end up with 3 times 3 is 9 on 4 times 3 is 12, this calculation here. Similarly over here, if we wanted to convert this to eighths, like we've done here, 1, 2, 3, 4, 5, 6, 7, 8, we'd multiply 4 by 2, make a 1, which would be 2 on 2, multiply them together, 3 times 2 is 6, 4 times 2 is 8. Similarly, if we wanted 16ths, I could divide this into 16 parts by splitting each of these into 4. So that's what I've done here. Then count up how many parts are shaded. Well, I'd have 4 from this part and 4 from that part and 4 from that part, which will give us this 12 parts shaded over here, out of a total of 16 parts. And we could do that with arithmetic by multiplying 3/4 by 4 on 4. 4 by 4 will give me 16 parts. 3 by 4 will give me 12 parts shaded. What if we wanted to work a little bit backwards? So this time we're looking for an equivalent fraction for a sixth that would have a denominator of 18. So I want the number on the bottom to be 18. I have to think about, well, what number do I have to multiply 6 by to make 18? And in this case it's 3. If I want to find an equivalent fraction, I have to have it as that number on itself and then multiply. So I've got 3 on 3 here. 1 times 3 will give me 3. 6 times 3 will give me 18. I'll end up with 3 on 18 as my fraction. If we're looking at it pictorially, if I have sixths and I want to convert it to 18ths, I have to divide each of these into 3 parts, which I've done down here, and I'd have 3 shaded parts at the end, which is what we found out from our arithmetic. Like the big challenge in this question is to think about what number could I multiply by 6 to make 18 to make this equation up. If you can understand that, then you are well and truly on your way to being able to not only add fractions in the next exercise, but add fractions with different size parts, which is a little bit more difficult. So I hope that was helpful. Feel free to watch it a few times if you haven't quite got it the first time, and in time you'll find it's one of the easiest things in the world to do. Thank you.